had some problems, like if you said, okay, show me projects that were in Afghanistan, it'll say, okay, here's Afghanistan, which this is the Netherlands. So things didn't always work out. That was one attempt. This is my personal attempt. Each little red dot is a suggested location where 8 projects occurred. You can see that there are some places that were probably recipients, like Mexico, for instance. I just wasn't trying in those places. So this is for 156 recipient countries using the OECD credit reporting system. But the problem is something like 50% of these, I'm pretty sure, are false positives. So remember, there's that one problem. Your input can talk about places, but that doesn't mean the project happened there. That doesn't mean that at all. Another problem is you can get, in this particular case, I was allowing for some typos, potential alternate spellings. There is collision between things like common English language words and actual place names. Sometimes, a lot of the time, there's a near collision. So for instance, in Egypt, I was saying, okay, allow for one typo because maybe something is spelled a little bit off. And a document would say the word about, and my attempt at this would say, oh, you mean Tabout, Egypt, which is a place, but that's not what the document was talking about. But if you don't allow, if you require perfect spelling every time, you will probably miss a ton. Oh, this is just for fun. This is from 2010, a map of where English language Wikipedia articles are talking about. And there's a pretty big inverse relationship between these two. So the places that Wikipedia talks about and the places that get aid, or at least one guess at where they get aid. You know, the English language Wikipedia is always talking about the DAC countries, basically, the big donors. So my question to you is, do you want to contribute to this project, and how might you? These are not our only challenges. I've really only talked about 2 kinds of challenges, geocoding, activity coding, and the problems we have with our inputs. But we have tons of other challenges. We have spatial challenges, for instance. And you might be, if your work is something like topology, that could be very fruitful for you. So this is just a little picture of people contributing. That was one of our, we have been sending students around to different partner countries, and they were in this town in Nepal, and everybody was working on a mural. So we have a couple sites you can look at. I'll send this presentation to you, and you can click on these links to see our website, our China site, where our inputs come from, and check out these links where we have, for example, a challenge for activity coding where you take some text input and come up with what list of activity codes are relevant to that text. We've opened this up to hackathons before, no one has gotten above 30%. That's the best anyone has performed for any of our sample inputs. So we're not doing so hot right now. So, yeah, and we have when I give you the presentation, you'll see these links, and on the China site in particular, you can look at photos that people have uploaded of these projects that are happening. So we must have questions. The question I have for you is what I've talked about relevant to your interests? I see some weak nods. Well, let's have a conversation. So maybe there's some challenges you foresee, or maybe you can imagine some good opportunities. Or you can just start to think about, how would I apply the skills I have now and my research interests to a problem like this? I'm sure there's plenty of possibilities.
So for the question of geocoding, can you tell us what's the eventual goal of geocoding is that you have all this name of places, so you try to I don't know, because for example in the climate modeling they actually really divide the entire Earth into smaller pieces. So maybe there are 5,000 pieces. Then maybe if you have a name, you can put this name into that piece. Is that something like that, or?
That is one possibility. So in my mind, that actually is the ultimate goal: is to get a gridded set of the world that shows amount of aid in each category going to that grid. That would be the easiest to work with. It would be a very clean output. What it looks like now is much more messy because our inputs are so messy. So an input document might say, aid was given to this district. So for that, so it says this much money was given to this district for this project. So we know where the district is, usually, but there's many problems there. One is redistricting. Like we just published a data set for aid Uganda has received last week or 2 weeks ago, and they redistricted in something like 2003, 2006, 2012. So trying to match those up is very difficult, for one. The districts keep changing. But we can say, okay, money went to this district, and money went to this other district, which is the parent of that district. And then this money went to the national government, and we don't know quite where it went. That happens a lot. Only about half the time can we say this is the town or city or mountain, river, road, etc. that aid went to and place that on a map. Only about half the time. The rest of the time, all we could do is make a guess. And there are many ways we could guess. We could say, some guesses seem reasonable, others don't. So one guess is aid money decays over distance. That seems sort of unreasonable to me. You know, like, here's where the aid money goes, and as you get farther from that, you get less of it. Like they were opened up the back of a plane and were just shaking out bags of money, you know. Another kind of assumption you could make is that aid is distributed equally over a known variable, like over surface area, which also seems ridiculous. That's like someone plotted out with strings a grid of this whole province, and they placed $1 in each thing. You know, of course that didn't happen. Even worse, so you know, it would make prettier maps, but even worse, you have assumptions like aid is distributed to the poorest people, which is a hugely problematic assumption, because then if someone says, okay, now that I have this data set on aid, let me find out how aid is distributed. Oh look, it's distributed to the poorest people. This is fantastic. You know, they would only discover the assumptions of your model. But, did I answer your question?
Sort of.
So, like, what will we?
I mean, it sounds like if you make a uniform grid, that's probably not a reasonable. Instead,
it's problematic.
That's somehow in mathematics, some people call this a multi-scale. In some place, you can probably have that grid, but in other place, probably they also have a hierarchy of a different size of a grid. So.
Yeah, we have district hierarchies. We have redistricting. Those are all challenges, basically, to how you would. This is actually, so as a person who does GIS, this is our biggest challenge. You can't really use this in a GIS the way people expect to use it. So what we have to do is produce an intermediate product that makes heavy-handed assumptions and then share those assumptions with people. That's pretty much all we can do. I think there was a comment.
I just want to know, how much of your data would you say is bad because it's just too messy and it's hard to interpret? And how much is bad because people deliberately lie?
Oh, we don't know. So we really don't know. So I just did this for fun once. Have you guys heard of Benford's Law? So Benford's Law is pretty cool. It's sometimes used to detect fraud in accounting. So remember, I don't know much about math. All I did was say, okay, Benford's Law, thanks. Let's see if it applies. Benford's Law says, we have the internet, so let's look at it. This is the distribution of leading digits in a natural data set you would expect. It says, okay, given something like populations of countries, or amounts of money that a company spent or received. Some kind of data set like this, lengths of rivers, perimeters of nations, any kind of data set like that. It says we would expect that if you chop up everything else and keep only the leading digit, then about 30% of the time that leading digit will be the number 1. And then something like 17 or 18% of the time the leading digit will be the number 2, and so on. And this is a way that you can catch people who are not very good at fraud. So I remember when I was in elementary school, we had to keep these journals. I don't know why they did this, but we had to keep journals of stuff like how much we were exercising. And I've never exercised in my life. I don't exercise. And it had to be like, how many sit-ups did you do? So I would say, 6, 8, 5, 4. I haven't done a 3 in a while. I'll put that in, right? So this is the same kind of mistake that people make when they're stealing money. They say, well, I assume the leading digits are distributed evenly, 0 through 9. But that's not true, typically. I don't understand why or when it's not true. I don't understand anything like that. But this distribution actually applies very closely to the OECD CRS. So if you look at the amounts of money that they distribute, and you look at leading digits, it does that. So I don't know if that's clever fraud because someone knew about Benford's law, or if it's because this is a distribution where Benford's law applies and there is no fraud. Maybe. But that's really the only kind of attempts that people have been making with this, as far as I know.
So then what do you do with data that may or may not be reliable? You still end up using it in the geocoding and activity coding?
So what is data like input documents?
I guess.
That's actually, I'm not close enough to those operations to know if stuff is getting thrown out because it looks super bad. I actually don't know. I'm sure that so if you look through documents, there are pots of gold in them. These documents can be, for one project there may be 15 documents, and one of them is 150 pages, and one is 2, and one is 1 page, and one is 6 pages. And somewhere in that 150-page document, there might be a sentence that gives you what you need. But as to the question of whether we would say throw it out because it's too long, I don't know.
I was wondering more if like an end goal. So once you've aggregated all this data and you've produced it in this viewable chart, then to what purpose? Like, what is the main purpose of having the aid data? So
the stated purpose is so that donors can give money more efficiently. So that if they have some target, like we want to give money to the people who are worst afflicted by something. So let's say HIV/AIDS mitigation. If you, there's a project called the Demographic Health Survey, the DHS, which tries to chart out for many countries where is under 5 mortality a problem, where is women dying in pregnancy a problem, where is HIV/AIDS a problem, for example. And our data would come in and say, well, here's where money is being given for HIV/AIDS. And the donor could look at that and say, we're not giving it to the right place. So that's kind of the goal, the imagined goal. But many other conclusions are possible. And I'm actually personally worried about things like, what happens if a recipient country says, we were distributing this aid, so aid came into our national government, and we were distributing this aid for water sanitation to the wrong caste. Let's rescind it. I think that might happen too. So transparency doesn't mean justice, but it's supposed to. That's the hope. Presumably, if we catch them doing that later, which might take years and it might be too late, then we can say, aha, we caught you, it was wrong, and don't do that again. But how much power do we have over them? Right? I don't know. So it's complicated. Transparency is supposed to lead to justice. It might not.
I know there are students on campus working with aid data now, but I don't know what they're doing. Are they just manually combing through source documents and pulling out info, or are they doing something else?
The great majority of them are manually going through those documents and pulling stuff out, which is why we're talking about topic modeling, entity recognition. Like, let's not do this if we can help it. Yeah, nearly all that time is spent just reading them and pulling out information of interest. Yes.
On a totally different topic, is there a lot of work being done on the natural language processing and like machine learning kind of topics for processing data?
As a proportion of all work, not really. So this has not become a major effort yet. There are a couple reasons. One is that the people who fund us believe in human beings, and they don't trust machines as much. And they also might, like myself, they might also not understand machine learning very well. So it's sort of like, you know, this was done by a human being, I know I can trust it. This was done by a machine, I don't think so. So that's one reason that we haven't been going all out on that. Another reason is we've done a bunch of attempts at this, and we've had hackathons where people have tried it.